Welcome to SQL Snacks, learning the features of SQL Server one bite at a time. Hi, I'm Bob Taylor, and I'm going to be your host for this series of SQL Server training short subjects. In this SQL Snacks, we'll cover the architecture of the extended event system in SQL Server. At the end of this SQL Snacks, you should understand the basic nomenclature and terminology related to SQL Server extended events. There's a hierarchy of objects that make up the extended event system in SQL Server. The highest level object is the module, which may be an executable such as SQL Server.exe or a DLL such as SQLDK.dll. A package is a container that contains all of the lowest level objects such as events. One module can in fact present multiple packages. So there's a one-to-many relationship between the module and the package. Then within the package, we should note that while there are 7 different types that could be, not every package implements all those types. For example, messages are less common objects in packages and are used mostly in the system packages. So what is a package? Well, a package are containers. Each package has to have a GUID and a name. You don't deal with that. That's an internal thing that Microsoft product group deals with. But by registering the module at load time, we can easily substitute a package. Say when SQL Server gets upgraded, the SQL Server package can easily be loaded at runtime with the correct version after you've upgraded SQL Server, so that it all just kind of works. We're going to take a look at each of the objects that can be contained inside a package. During the demo, we'll take a look at examples of events. For those of you who are familiar with .NET listeners, this is similar in nature. The SQL Server developers are responsible for putting explicit code in the SQL Server source to expose an event. Much like a debug trace listener, if no one is subscribed, it is basically a no-op. In most cases, the schema belonging to an event will be fixed, but as we move from version to version of SQL Server, it may change. It's just something to be aware of. One thing that does change are the maps. You must be aware that event IDs, etc., may change from version to version, which is why we're going to have map tables. If you think in terms of a producer and consumer architectural design pattern, a target is a consumer. The events are the producer. If no target is configured, then events will not be consumed. Pretty straightforward. Targets are agnostic when it comes to the events. They can be a consumer for any type of event. There are multiple target types, some of which are quite sophisticated and allow for advanced troubleshooting. For example, there is a target that will tell you when a starting event, such as a begin transaction, does not yet have an ending event. This is a great way to identify long-running transactions. Targets are key to the flexibility in the system, and we'll examine them in their own SQL Snacks section. Actions are what we want the event to trigger. So in the case of a severe error, trigger a mini dump. Or if a query takes longer than 1 second to execute, capture its query text or plan handle. Actions can also do things such as create histograms of event occurrences. Again, we will have a SQL Snacks session on actions. Predicates act like the where clause in a Transact-SQL statement. During the demo, we'll examine the predicate sources and predicate comparisons that are available. So you could, in fact, capture an execution plan every 25th time a particular query is executed if you wanted. The sky's the limit, really. You're only limited by your imagination. Next, we're going to go to SQL Server Management Studio and take a look at these objects and the system tables that contain them. Just so you're aware, all of the source code for these demos will be made available along with the SQL Snacks up on my blog site. So let's take a look at the XE Packages Dynamic Management view. And we can see here that we have 16 different packages that SQL Server currently leverages for extended events. Some of them, for example, the security audit events, are for internal use only. So the capability is marked as 1 and the capability description is marked as private. Package 0 contains all of our standard maps, data types, predicate compares, actions, and targets. Each other module is then allowed to extend that system by adding their own maps, operators, actions, and targets, and so on. So this is the list to date with SQL Server 2017. If we want to see which modules implement the package, we can run this query, and you can see that most of these are implemented in DLLs in the SQL Server namespace. So we're going to take a look at the different types that exist in the XE objects. And this corresponds to the types that we saw in the slide during our presentation. If we need to understand how many different objects there are of each type, we can run this query, and this is where I got the count of 1511 for the number of events that are currently exposed as of SQL Server 2017. We can then take this basic query and modify it for each of the types so that we can get some more information. Here we can see that there are different types, and these are the data types that are defined for the data fields that are provided or can be consumed in an action. And it tells you which package they are actually contained in, how much data storage they require, and so on. So these are the types, and these are the ones that you'll see when we show you the UI in Management Studio in a future SQL Snacks. You'll see these listed as the data types. If we want to look at the events, here you can see all of the events that SQL Server currently supports. And there are, like I said, over 1,500 of them. So just browsing through these can be difficult. They do have a channel associated with them, and when we display the UI and show you how to create a session using the session manager, you'll see how we can limit what it is that we have to scroll through in order to decide what events we want to capture. Targets are interesting in that we have several different target types, 18 to be exact. Some of these, like the ring buffer, are used very heavily. It's just an area of memory that's set aside, and we'll talk more about that when we do our SQL Snacks on the targets. But some of them are interesting in the fact that we can do a histogram or pair matching, and we did mention those, but we'll go into greater detail during the SQL Snacks on targets. So here we're looking at the predicate comparison types, where it's defined as an equality operator between two 64-bit unsigned integer values. So if you have a data element in your event, you can use a predicate compare to compare that against the value in order to filter the output or whether or not the action is fired and something is written to the target. Likewise, we have predicate sources, which are the columns within the individual events that we can compare to. And the main thing is the UI handles all of making sure that the type name matches when we're doing our comparisons in the UI. If you're doing this with Transact-SQL, then you have to make sure you're using the correct comparison operators. In most cases, what I would recommend is to use the UI, and there is a script button. So if you want to check the script into source control or to be able to have it portable with you so you don't have to recreate it at every customer site, you can carry this kind of a toolkit with you of predefined event sessions that you can then run during your test engagement. Likewise, the map it says, hey, for this name, here's the description, here's the type size, and here's the GUID that it's going to be associated with. In many cases, this map is varying by version of SQL Server. So this number here, for example, the event operation code of 174 may change from version of SQL Server to the next version of SQL Server. So you always want to use the map, the XE map, in order to map the textual values that you want to the actual current number values. And likewise, the messages are mostly internal, but these are where extended events can put pre-formatted messages that has parameter substitution to be recorded in an event log or in an error log or in the event viewer, so on and so forth. Now we have seen the system objects that comprise the extended event system. You're probably wondering, how do I use them? The user objects that are created to interact with the XEvents system are known as sessions. When you create a session, you add events, actions, and predicates and specify a target for that session's output. The session is a security boundary in a separate execution space. So a global counter in session A could not interact with one in session B, for example. We do have the ability to track causality, i.e. this query took a long time to execute because the other query was blocking. Very powerful, but it does add a bit of overhead. So now that we've examined the basic architecture of the extended event system and looked briefly at all the objects that we can include in our sessions, next we will do a deep dive into the individual objects and how to wire them up in SQL Server Management Studio. Well, thanks for listening to this SQL Snacks. And as always, if you have any questions, please don't hesitate to reach out to me. I have several email addresses and other ways to contact me listed here on the slide, and also some links to some of the projects I've shared with the community.